Hello, my name is Perry Hoeks. I'm a Senior Area Sales Manager for KOMA since many years. In this coming video we will try to show you a little bit about our control panel, which basically is the heart of the cold technology equipment from us. In this coming video we will show you how a touchscreen K-Control computer has been designed to optimize and control all parameters in all phases from cooling down to the end proofing process. This we can do by optimizing all phases in temperature, airspeed and humidity. The goal is of course to condition the product from the incoming temperature to the end proofing temperature. K-Control, designed to optimize all phases. What we see in this slide is that we can graphically show and see what the room is doing in which phase. Basically we're talking about 4 phases: cooling phase down the product, to heat up the room whenever a product needs to go into a proofing phase. At a certain point you need to humidify the air, and we have to make sure that the dough in this area should not be dehydrated. Basically it is to optimize the product in all phases with the right temperature, with the right air and the right humidity. This is why we open up the whole process and is graphically visual for our people. To clarify the graphic a little bit more into detail, looking at the lowest point where it says the 0, we see whenever the curve goes down, that's the phase where the products are being cooled down in temperature. Once temperature going up, you see the curve above the 0. Further in blue, you see the humidity availability in the room, which in the end, as soon as the product needs to be proofed, we will add some extra humidity. The last point you can see is very important for us as technicians, to look at the airspeed and the control of it. Does it need to be continuously, automatically or in pulsation, which I will clarify a little bit later. Important to see in these phases how does the product react to its room temperature. To show you a very poorly bad working program, you can see a lot of curves moving up and down in this slide. Important for our baker, if he's at site, to optimize this program to be able to get a quiet, functioning, working installation. Over our monitoring department, by the way, it's also possible to integrate in these phases and to optimize from a distance. Let's show you a little bit what's important in this phase. In all these phases you can see a very bad working installation. Mainly you can see that in the morning when you come in the bakery and you see a bad proofed product. Because of this environment, to keep it open in parameters, we can define and justify to get an optimized quality out of the product. Most important in these parameters is of course the time and the temperature. To get a stable unit, you just add humidity and heating whenever it's needed, and to keep the room as quiet and stable as possible. In this slide we will show you 6 phases which we programmed for a certain procedure in product. You can program up to 10 phases, but normally you can see for, let's say, the main coming products that 6 phases is sufficiently to do the optimization. You start with the product bringing in, and of course you know the time of being baked in the morning. So these 2 time periods are essential in programming all the other phases. In this case, as an example, phase number 1 is the phase where you bring in your products. That takes about 2, 3, sometimes 4 hours. After that we program a phase where you keep the products for a certain time on the same temperature. The first product came in 4 hours before the last product came in. The third phase is a phase you cannot program in time, because that's defined by the computer, because you know in the end the baking time and the product bringing in time. So that needs to be a flexible time to be programmed by computer. The fourth phase is slowly bringing up the product in temperature to start creating a proofing experience. And phase number 5 is the end phase of proving. Last phase is to keep the product basically on a stable temperature and humidity to be able to bake off or to keep the product for a certain period as well. Times are being programmed with certain temperatures. Towards these temperatures, you also need humidity, air, fan speed, and dehydration, yes or no, drying, as we call it. As an example, for these kind of products, we took a drying period, which we left out because basically you need to keep the stable humidity temperature of the room itself intact. Therefore, you can program air speed in continuously, but also in automatic speed. That's what you see in the separate phases. To conclude this slide, basically 6 phases: temperature, humidity, air speed, continuously, automatically, dehydrate, yes or no, all parameters you can adjust to your specific product. This is just one day you are programming. And in the next slide, you will see you can also program this one day into a week program. Looks a little bit like this in the computer. So this slide shows you on the top view how a week program and a day program looks like. We just saw this graphic in parameters and phases which we can program. For you as a customer, you can also find out the optimum temperature and humidity phases by just checking and measuring your product. What we will find out then is that basically with the parameters you should create a climate in temperature and humidity which the room temperature narrows also the core temperature of your product. The more closely it gets to another, the better humidity, air environment of this product in conditioning phase it will create. That's what you see in this slide. In the coming 2 slides, we show you how core and room temperatures in the same conditioning unit vary towards a fresh bring-in product or a frozen coming-in product. What you see in the blue is the room temperature, in red the core temperature of the product, which shows you directly what influence a frozen product bringing into a conditioning unit will give you for a quality of your end product. In the phase where you start proofing, you add humidity. Important is that your product and your room environment is stable over all phases. So to add humidity is only needed if necessary, demanding from the environment. Important is that at the end of the phase after conditioning, the room should be dry. What we create in this humidity environment is a humidity phase from left to right, bottom to top, front to the back, one stable climate to give all products the same humidity environment. Our principle of humidification is based on a very small delta T towards the room temperature. This means basically 1, 2, 3, 4 degrees higher as the room temperature should be the air humidified. This basically makes sure that the room doesn't heat up too much, so that your cold doesn't need to come in that often, which gives you an unstable conditioning climate. Therefore, the product is being formed and proofed in a very stable environment. Summary. We saw all kind of phases. Important phases in all the parameters is time, temperature, humidity, and air circulation. To be able to get an optimum product quality in the proofing process, you need to verify the most essential parameters for your product. We make sure energy consumption will be as less as possible. So adding humidity, adding heating only when demand in climate is being forced. Summary again, conditioning units. You bring in a product which is produced in your line or by hand. Important that this phase also is recognizable quality, bringing product towards the conditioning unit. Once you don't bring a good product, we cannot create a better product. Once the product is proofed, of course, the next phase will be processing, baking, bringing to the shop and to your customers. 3 very important phases where we are one of the 3 which can help you qualifying and clarifying a better product. Conditioning units. K-Control is a part of the process which defines a better quality of product. Hope you enjoyed our video. Get in touch with us over email or phone. Hope we can help you further. Thank you for watching. KOMA. Constant quality. Constantly.